Okay. That's what's happening here. When x is 3, and g of 3 is 9. Okay. When x is 1, so here we're saying what's g of 1. So when x is 1, we want to evaluate the function, so we're getting g of 1, which is 8. Okay, so that's what happens here. Okay, I've given a question like this on exams, and what students have done, if I ask them what g of 3 is, they'll go here to 3, and then they'll say g of 3 is 2. But they're reading it backwards. So, you want to make sure you read it correctly. Okay. Now, here's another one. Okay. Here, we're going to solve an equation involving a function. We're solving an equation involving a function. Okay. Now here, what we're going to do, we're going to find all x here such that g of x equals 8. So we want to know what inputs, what x values give us 8 in the function. So here, we have to look at the table, of course. So here we have an 8. We have the output is 8. So what's the x value? 1. Okay, so if x is 1, we get 8. But is that it? Let's see. Not here, not here. Oh, here we go. X is 4. So if x is 4, g of 4 is 8. So that's also another example. That's another solution. So we have 1 and 4 that if you plug 1 into the function, you get 8. If you plug 4 into the function, you get 8. It's still a function because remember, notice that each x value gives you only one y value. I mean, you might have different x values that give you the same output, but that's okay. If I plug 1 into the function, I can't get 8 and something else. Here's this one. Let's find all x's at g of x is 3. Well, if x is 2, so we want all x's such that g of x is 3. Here we have 8. Okay, here we have 3. Now, what's the x value? 2. So notice I found 3 as an output, and since 2 is above it, we see that 2, if you plug it in as x, you get back 3. So 2 is one x value. What about over here? Well, this is 9, so that's not what we want. Here's 8. No. Oh, here's 3. So we have g of something is 3. What is that something? 5. So if x is 5, g of x is 3. So g of 5 is 3, g of 2 is 3, so 2 and 5 are the solutions. That's what we're doing here. What about the last one? We want all x such that g of x is 1. We want x such that g of x is 1. Okay, well, is there an x such that g of x is 1? Well, here we have 8. Here we have 3. 9, 8, 3. Well, you can see that 1 is never g of something. It's never a y value. So there's no solutions. Okay, 1 is never a y value. It's an x value, but it's never a y value. So no x such that g of x is 1. Notice here the top row is also the domain. That's all x's. All y's is the range. So the top row is the domain. The bottom row is the y. Okay. Let's do this one. Let's do this one. Let's suppose now g is a function defined by this table. Okay, so this one's a little bit different. Let's find g. Let's find these values. We want to find g of -3, g of -1, g of, all x such that g of x is 1, all x such that g of x is 0, all x such that g of x is -2. Okay, so let's do that. Okay, well, from the table, what's g of -3? Well, when x is -3, here we go. The corresponding y value is -29. So we get -29, as you can see. What about g of -1? Well, when x is -1, okay, what's the y value? 0. So g of -1 is 0. I thought I missed something. So here, now we're solving an equation involving a function. Solving an equation involving a function. We want all x such that g of x is 1. So all x such that the y value is 1. Not here, not here, not here. Oh, here we go. So what x value gives us 1? -4. So -4. Okay, what about this one? Find all x such that g of x is 0. So here we want all x such that the y value is 0. Oh, here's 0. X is -1. That's 1. This is 13. So no, not -29. We have 1. Oh, here's 0 again. So we have -5. So when the y is 0, x is -5. So this is saying g of -5 is 0. G of -1 is also 0. So just -1 and -5. Okay, so that's good. What about here? Let's find all x such that g of x is -2. Well, is y ever equal to -2? No, 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 no. It's never equal to -2. So in other words, y is never -2. The function never gives us -2 as output, so there's no solutions. Are there any questions on this example? Okay, here's another one. Now remember, a function can also be represented by a formula, right? A function can be represented by a formula. The idea there, remember, is f of x is our output, x alone is our input, and what happens is the function here, it's going to do some calculation with x. That's how you get the output. So the machine, if you go back to that machine analogy of functions, in this case, okay, the machine is basically just some algebra, so to say. It does some calculations with x. Okay, so here, what is the function doing? Well, it's taking x as your input and it's giving you back 8 times x plus 9. 8 times that x, so it's multiplying your input by 8, and then it's adding 9 to it. Okay, well, let's evaluate f of 2 and f of -1. So in this case, we're taking x to be 2. F of that, What's the output? Well, it's 8 times 2 plus 9, which is 16 plus 9. 16 plus 9, and of course that's 25. So that's what we get here. What about -1? Well, for -1 in this case, when x is -1, f of that, right, that's going to be 8 times -1 plus 9, which is -8 plus 9, which is 1. So in this case, the input is -1. What does the function give you back? 1. That's what happens here. Good. Okay, so here we evaluated a function. Here now, notice, we're going to solve an equation involving a function. Okay, first let me take care of the recording.